Hello guys. Welcome to our channel ChandraAwesome. In this video we will learn how to design hyperboloidal gear. In the social media you might already seen this gear animation. So today we will achieve this with simple steps. The hyperboloidal gear nothing but the helical gears with same axis direction. Open the new part studio to start the design. Here we need helical gears. For that, select the spur gear feature script which is available in custom tools. Here we need center gear, which is bigger than the other four. For me I am giving the values as shown. First of all give the helical angle of 5 degrees of either clockwise or anti-clockwise. Like thickness of 3 inches and pitch diameter of 1.5 inch. Now we need the cone shape like this on the flat faces of the gear. For that, select the face and draw the circle sketch as shown. And finish the sketch. Select the drawn sketch and extrude a cylinder of 0.3 inch as a new part. Now chamfer the edge as shown here. Here I am using the example dimensions. If you want you can also work with your own dimensions. Hide the gear. Now select the sketch as shown. Extrude the sketch. In the extrude tool, select the intersect section and remove the intersected area as shown here. Unhide the gear again. Now select the transform tool. In that select the cone part as an entity. Select the type as for mate connectors. Now select the face of the part and select the face of the gear as shown. Do not forget to select the copy part to make duplicate part. But here you can observe the faces are not matched like the upper face. For that, click on the mate connector option and rotate the gear till the face matches near or exactly. After match the faces exactly, boolean them using the boolean tool and union them. Now hide the center gear. And add the another helical gear with the same dimensions of the previous gear except the pitch diameter of the gear. Keep it as the 1 inch dia. Here you have to observe that the module is different from the previous one. For previous gear, the module is 0.06. So, here you need to have the same module or near value. To achieve that, change the number of teeth till the module reaches the required value that is 0.06 or near value. Here we got 0.059 which is near to it. So fix it and save the changes. Now, repeat the same operations what we have done to the previous gear. That is, add the cylinder, chamfer it, use the transform tool and match the faces of the duplicate part. We got the 2 gears. Now, use the transform tool again and move the small gear to its position. To know the position, do the simple math. Here the bigger gear have 1.5 inch diameter, half of it is 0.75 inch. And for small gear it is 0.5 inch diameter. Total distance is 1.25 inch. Move the gear with that distance and add 0.01 inch tolerance to the distance. As you see, the gears are not yet positioned correctly. They are overlapping each other. So we have to rotate or tilt the gear, that teeth will placed exactly. Draw the sketch as shown in here. This line will helps as an axis to tilt the gear to its position. Use the transform tool again and select the rotate as the type. Select the line as the axis to rotate. Now add 10 degrees rotation as per respective direction. Finally the position of the gears are done. Now pattern the gears using the circular pattern feature. Keep the count as 4 or else you can as per your wish or design. After that, save the feature. Now add the sketch as shown on the center gear to add the frame for the gears to hold them at their position. Now draw the circle and also the position of the gears using the Use tool and the Slot tool for simple drawing frame. This is the final frame. You can also add your own frame design just to hold the gears. Select the circular faces of the gears. And use the Thickness tool to increase the thickness of all gears equally. Make sure the thickness should intersect the frame. Select the bottom faces as well. Now finish the thickness feature. Select the Boolean tool and select the Subtract section in it. Remove the gear parts from the frame. Therefore, the frame gaps will be generated. After that, select the Keep Tools checkbox to have the gears still for use. We finally completed the designing the gears. Now we have to do the assembly and its animation for the design. Create a new assembly tab and insert all the parts required from the respective part studio. First, delete the down frame, because we did not added the gear positions gaps to it, and fix the top frame in the assembly. Now we have to work with mate connectors. Move the all gears a bit down so we can assemble easily. Use the Revolute mate connector to all the gears and frame respectively within their positions as shown. Now select the frame part, right-click there and copy the part and connect to the base of the gears using the same Revolute mate connector. Now use the gear relation feature. And select the Revolute mates of one small gear and the center gear respectively. Add the gear ratio value here and save the feature. If you don't know how to calculate the gear ratio, watch the assembly relations video which I had already attached in the description. Repeat the same with the other gears as well, just like we added gear relation with the same gear ratio value. After added the gear relations, check the animation by dragging one of the connected part. After the animation working, you can see the parts are overlapping each other. To change the overlapping, Change the position of the gears by rotating them in its position by editing Mate Connector and rotate it over Z-axis as shown. Repeat the same by editing Mate Connectors until you satisfy to get their positions without overlapping each other. After the positions are changed with satisfaction, right-click one of the Revolute Mate and click on Animate and click the play button. Then you can see the animation of the gears and how they are moving each other. Let's add the rendering materials to our design using the Onshape Render Studio. To access the Render Studio, you need to have professional account. Actually, it is free for 6 months the users who have company. Once you open the Render Studio, this is the interface you can see. Now click on Create and select our assembly design we did and create the scene by pressing the Create button. Once the scene created, you can see the interface like this. Preview and the materials to add. You can add the materials by selecting them using the Alt key plus left-click drag to apply the whole part. And press Shift plus Alt plus left-click drag to apply the face of the part. You can also change the background either a solid color or image. Once the materials, light and other scene settings applied, select the Render to Onshape option. Therefore the rendering works faster and will save it as a tab. Here the rendered output. You can also download this to your local disk and can see the images in Onshape Mobile as well. That's all about in this video. If you like the video and concept, please do like, share, comment and subscribe our channel ChandraAwesome. Hope it will helps you. See you soon with the new tutorial or concept. Thanks for watching.